Good morning, dear students. Today we are going to see analysis of algorithm subject. First, I introduce myself. My name is Pondi Rajan. I am an assistant professor in the Department of Information Technology in Hindustan Institute of Technology. Today we are going to discuss about algorithm. What is meant by algorithm? You want to understand. Then only you can solve any problem. You can write any programming code. For example, C programming in Java, Python. If you are writing any code, first step you want to write algorithm. How to solve that problem? Algorithm is nothing but algorithm is a step-by-step instruction to solve a particular problem. Okay, this is you want to understand. We can through algorithm we can give one or more solutions we can solve. Without instructions, without pre-planning, we cannot solve the problem. So first step you want to write algorithm is much important. Next, algorithmic performance. Generally, algorithm we are writing to solve a particular problem. We can write more algorithms. We can write. We can use different types of methods. But how to evaluate this algorithm? This algorithm is very best algorithm or worst algorithm. How to identify it? So we can calculate the algorithm efficiency. Only we have two methods. The two methods is one is time efficient, time complexity, and another one is space complexity. What is meant by time complexity? Time complexity means how the algorithm for execution purpose it will take how much time to execute that algorithm, how much time to execute the number of instructions. This is time complexity calculation for evaluating algorithm. Next, another aspect is space complexity. Space means one algorithm, how much memory space it will take to execute that algorithm. That is called by space complexity. Okay, generally, simply I can say the time complexity means how much time it will take to execute that algorithm. It is time complexity. How much memory space it will take to execute algorithm. It is space complexity. Okay, this is the for evaluating the algorithm. Evaluating the algorithms. Next, analysis of algorithm. We can analyze the algorithm. Analysis of algorithm is a computer science and provides the tools to analyze the efficiency of different methods of solutions. How do we compare the time efficiency of two algorithms that solve the same problem? Okay, we can write more number of algorithms to solve a particular problem. This is the analysis of algorithms. Next one is how we start the analysis the algorithms. For example, when we analyze the algorithm, we should apply mathematical techniques that analyze the algorithms independent by specific implementations on computers or data. To analyze the algorithms, what are the steps we need to first we want to the first step is we start to count the number of significant operations in a particular solutions to assess the efficiency. Next, second one is then we will express the efficiency of algorithm using functions. Okay, these are the analysis of algorithms. Next, the execution time algorithms. Each operation in an algorithm has a cost. Each operation takes a certain of time. For example, the number of in algorithm, how much instructions need to solve a particular problem. For example, we want to count that algorithms. For example, count equal count plus 1. Take a certain amount of time. It is in constant. For example, in our algorithm having how many steps, how much time to execute that algorithm, how much memory space it need to execute that algorithm. We want to calculate this. This is the sequence of operations. For example, how we can calculate the time complexity in practical manner. We are going to see that how count equal count plus 1, store the one variable c1, and sum equal sum plus 1 count variable. Finally, we want to calculate the total cost equal c1 plus c2. This is the execution time of algorithms. Next, the execution time of algorithms we can call for simply we can take one if else statement. For if else statement, how to calculate the time complexity? We want to understand that. First, if n less than or equal 0, true block will contain absolute value equal -1. For absolute value -1, it will take the time complexity, it will take the count values. Okay, the count value is 1 for a true block. On false block, absolute value equal to n. This is the false block. It will count by, for calculating the time complexity, we can give the value is 1. Finally, we want to add these counts and calculate for time complexity. Now we can how many times, for example, if n less than 0, this is the how much count, 1 count. And true block, how much count, the 1 count. And else block, how much count, 1 count. Okay, by these 3 counts we want to add and calculate maximum value. Which one is maximum? We want to take that for time complexity. Okay, this is the if else statement for how to calculate the time complexity. We see. Okay. Next, we are going to take one simple loop statement. We are going to take for looping statement, how to calculate the time complexity. For example, in loop statement, we are going to take the loop is while loop. While loop, all syntax already you know that I equal to 1. Okay, I equal to, this is the variable declaration. Okay, this is the initialization. In we are going to calculate the count is 1. Next, sum equal to 0. We are going to calculate the count value is 1. And while I less than equal to n, this is the count. This count is n plus 1. And I equal to I plus 1, this count is n. And sum equal to sum I plus I, this count is n. Finally, we need to calculate all the sum values. We want to count all the values. We want to add these values. For example, 1 n plus 1 n, these values we want to add. After adding, we are going to evaluate the time complexity values. Which one is the maximum value? That is the time complexity value. We can take that. And next, we are going to take one another loop, the execution time of time complexity. For example, nested loop, we are going to how to calculate the time complexity for nested loop. We are going to see now. I equal to 1. This is the syntax of nested loop. We are having already one while loop. Within the while loop, we are going to declare the another while loop. Okay. For example, this is the syntax. And I equal to 1. We are going to count the 1 value. And sum equal to 0. We are going to count the 1 value. And while I less than equal to n, value is n plus 1. Next, j equal to 1. We are going to give the value is n. And while j inner while loop, we are going to give the times count value is j less than equal to n. This value was n star n plus 1. Next, sum equal to sum I plus 1 and n star n. Next, j equal to j plus 1 n star n. And next, I equal to I plus 1. This will go to n. We are going to give the value is n. Finally, we want to add all the values and take the maximum value. That value is a time complexity value for this nested loop, nested for loop. Next, general rules for estimation. General rules for estimation. Loops, the running the time of loop is most the running time of the statements inside the loop times and number of iterations. This is calculations for loops. And next, nested loops. Running time of nested loops containing a statement innermost loops, running time statement multiplied by the product of the nested loops. Next, consecutive statements and if else statements. Next, and we are going to the algorithm growth rate calculations. After that, this is the growth rate of the count and how to calculate the compare the two algorithm time complexities. This is the value. Next, common growth rates for c equal to constant values log n. This is we can calculate the logarithmic log squared n, log squared, and n equal linear value, n log n, log linear arithmetical value. N squared means you can calculate the quadratic time complexity, the cubic time complexity, exponential time. These are the time complexity types. Okay. Today class is over. Next we are going to see another class, all the asymptotic notations. Okay, thank you students.